Dear learners, welcome to my channel. Today we will discuss about flame emission spectroscopy. Flame emission spectroscopy is nothing but it is one of the analytical technique. It's most probably they are similar to the colorimetry instrument. This is Dr. K. Sheila, Assistant Professor in Biochemistry, Sacred Heart College, Autonomous, Tirupattur. So, flame emission spectroscopy introduction. Flame photometry it gives the more accurately result. So it will called as flame atomic emission spectrophotometry or flame atomic emission spectrometry. It is also used to determine the concentration of certain metal ions, among them sodium, potassium, calcium and lithium. So this type of technique it will be useful for the determination of concentration of certain metal atoms. It is also used to measurement of intensity of the light emitted when a metal is introduced into a flame. So the title is, since is nothing but the flame, with the help of a flame it need to determine the sample concentration. So that's why we need for the flame. So this type of the flame emission spectroscopy, first we are introduced into the metal into the flame. So what is the basic principle? When a solution of metallic salt is sprayed as fine droplets into a flame. So any type of the solution like a metal atoms of the or metallic salt contains of the sample, they are sprayed fine droplets into the flame, so that like a metal ions of the sample introduced into the flame. So always you know about that the flame is, since is nothing but the productions of heat, burn. So due to the heat of the flame, the droplets dry, leaving a fine residue of salt. This fine residue converts into neutral atoms. So the main concept of the flame to neutralize the particular metallic salt. Due to the thermal energy of the flame, the atoms get excited and thereafter return to ground state. So the thermal energy they are productions from the flame. So any type of the atoms to get excited, they are the two different type of the state is there. One is a ground as well as the excited state. So once they are in the excited state, they are returned back into the ground state. So finally, in this process of return to ground state, excited atoms emit radiation. So this places two processes it will be occur. One is a flame, the metallic atom they are introduced into the flame. In this process of return to ground state, they are excited atoms emit radiation. So the excited atom they are occurs in the radiation of specific wavelength. So already everyone know about that, like a wavelength since is nothing but they are productions of the rays with the help of the radiation. This wavelength of radiation emitted in specific for every element, each and every element. Okay. The next one, any type of the samples or solutions we are determined in the one way qualitative as well as a quantitative. The wavelength of the color tells what the element is will be present, means that it's called nothing but qualitative. The colors of intensity tells us how much of the element will be there, like it will be process, it will be helpful for the quantitative. So the two process of the main important in the determination with the help of the flame emission spectroscopy. So I hope you everyone to know and clear principle about the flame emission spectroscopy. That is the main process. The first, initially the metal atoms, they are introduced into the flame, and once they are introduced into the flame, they are the excited state of the atoms, they are returned back to the ground state. So the particular wavelengths they are produced for every element. So each and every element, they are productions of the color, like the color will be tells the qualitative, it since is nothing but the development of the color, and they are the much amount of the element will be there, means like a determination of quantitative. The next one, this structure show that the instrumentation, like clearly how to they with the help of flame, finally they are determine the what type of the element will be present in the quantitative and followed by the qualitative. So first one, we are take to the metal atoms of the sample, like that is nothing but that is a solution, and also the followed by it needs for the some compressor to hair from compressor free to contact with the metal atoms, and also then with the help of these hair compressors of the solution, they picked up the sample from the container, and it will be thrown into the another container in the form of the like a introduced into the flame. Okay, like a metal atoms, they are introduced into the flame. They that near by the flame, like a nebulizer, that is a conversion of like a metal atoms of this nebulizer. The metal ions, they are recognize the excited state as well as a ground state. Then followed by monochromatar filter, it will be there. That is nothing but that is a conversion of polychromatar into the monochromatar. And finally, with the help of the lens, they are determine the elements, what type of the element is will be present in the help of the detector and the recorder. I hope everyone clear about that instrumentation. That is a flame emission spectroscopy. We must need for the detector. So again we will discuss what are the parts is there in the instrumentation. So first main part, we need for the sample of the or the solution, like a metal atoms is there. With the help of air compressor, they have the sample will be out into the nebulizer like a fuel flame. So they are metal ions and elements, they are nebulized. Then the next one, filter, they are used because of the conversion of polychromatic into the chromatar, like a monochromatar. And finally, with the help of the lens to show what type of the element will be there, it will be present in that particular sample. Yes. The next one, this set of apparatus to show that same structure, flame emission spectroscopy. Already you know that the nebulizer and data display means since it's nothing but they are final reading out, and also the one type of the filter, they are conversion of polychromatar to the monochromatar, and this type of the instrument we must need for the flame. So and certain limitation also there is nothing but limited number of elements that can be only analyzed. Okay, so here one drawback, like a limited number of elements that can be analyzed. The sample requires to be introduced as a solution into fine droplets. Many metallic salt, soil, plants and other compounds are insoluble in common solvents. Hence, they cannot be analyzed by this method. Since sample is volatilized, if small amount of sample is present, it is touched to analyze by this method, as some of it gets wasted by vaporization. Further, during solubilization with the solvents, other impurities may mix up with the sample and may lead to errors in the spectra observed. So the first limitation since is nothing but the limited number of amount of elements one be analyzed. The sample requires to be introduced as a solution to fine droplet many metallic salts, soil, plant, and other insoluble in common solvents. Hence, they cannot be analyzed by this method. So, different type of the metallic salt is there. They are diluted in the solvent. Some of the metals there is no diluted with the help of the solvents. Since sample is volatilized, if small amount of sample is present, it is touched to analyze by this method. As some of it gets wasted by vaporization, further during solubilization with the solvents, other impurities may mix up with the sample and may lead to errors in the spectra observed. And also, some application is also there. This type of the flame emission spectroscopy to estimate sodium, potassium, calcium, lithium, etc. level in the sample of serum, urine, CSF, and other body fluids. So here they are estimate to the sodium, potassium, calcium, lithium. The sample will be present in the body fluids like a serum, like a blood sample, urine sample, CSF, and other body fluids also. Flame photometry is used for the determination of alkali and alkaline earth metals. It is also used to determinations of lead in petrol, used in the study of equilibrium constants involving an ion exchange resins. And also it is used in the determination of calcium, magnesium in cement. So here the applications of the flame emission spectroscopy. So the main applications they are determine the fluid to estimate the sodium, potassium, calcium, and lithium in the body fluids. So, flame photometry is used for the determination of alkali and alkaline earth metals. It is used to determination of lead in petrol and also used in the study of equilibrium constants involving in ion exchange resins. And also is used in the determination of calcium and also the magnesium. It will be present in the cement. So, thank you all. I hope everyone clear this topic. We will see the next lecture class. Thank you.